Sounds good. Do you want to share, Mariel, or should I?
Go for it.
Okay, 1 second. Okay, can you guys see that? All right, great. So like they mentioned in the introduction, we're going to be going over a little bit today about Code Reviews 101. So we're not sure how many of you are in software specifically, or maybe other areas of tech, but we hope to make this as approachable for everyone as possible. And it's an interesting thing to learn about, we hope, even if you aren't necessarily going to go into the software field. Mariel, do you want to go ahead and introduce yourself?
Yeah, just to introduce myself, my name is Marielle. I'm a senior software engineer and tech lead over at PathAI.
And I'm Ella. I'm an entry-level software engineer. So I graduated from biomedical computing just back in August, or sorry, back in April. So was in your position in undergrad not long ago, and now a software engineer as well at PathAI.
And we'll talk a little bit more about PathAI and answer any questions you might have about us at the end. But to introduce the topic at hand, we thought code reviews would be a good topic to cover with you guys, just because it's going to be a big part of your career. And the reason for that is, like, ideally every change to the code base is reviewed by one or more of your peers. So like every line that you might write and every line that your peers might write will be looked at by your team. And so how this typically works is you would work on a feature and bug fix. You would submit a merge or pull requests, which are basically the same thing from different perspectives. Then your teammates would review the changes, make any comments to make sure that it actually solves a problem that you were trying to solve, has unit tests and system tests around it, and adheres to a style guide that your engineering team might have. And then you would need an approval before you merge it into a repository. And depending on the project, you might then deploy it to an application.
So there's a lot of purposes for code reviews, besides the most obvious being that they help to validate correctness of the code and the quality. But they're also just really part of a healthy engineering culture altogether, and can help promote teamwork, because you get to know how your coworkers think, and you get to keep up to date on what they're working on. And also people really respect that you're taking time out of your day to help review their code, and vice versa. It also helps to make sure that everyone's following the best practices set, and that there's consistency among all the code changes. It's also really a win-win, because you get to improve your code literacy by reading a bunch of code that other people have written, and you also get to improve your own code quality by getting feedback from other people on your team. And I can say, as a junior developer, code reviews have definitely been one of the most helpful ways to learn more about the code base you're working on if you're new to it. So even if you're not necessarily reviewing with a ton of context or to make a lot of suggestions, it can be helpful just to read through stuff, to ask some questions, and to keep up to date with the changes that others are making.
And then some small best practices to think about when you're going to submit a merge request. So to give everyone context, you want to give a description of the work, context around the problem, and some specific things to look out for. Once you have that kind of context, the code itself, hopefully it's on the smaller side, no more than like a few days of work. And the reason for that is, like, the bigger it is, the less people are likely to comment on it. And I have this graphic on the left where each of the dots are like a data point, and the number of lines of code. And the red line is the number of defects that are identified. So you can see that the smallest reviews actually have the most comments, which is pretty interesting. And if someone submits like a really large code review, people are less likely to say things. They'll just kind of like skim over it and only comment on um, maybe like high level things. And so it's important to keep your merge request small for the sake of your own quality, but also to help keep your teammates sane. And then finally, it's helpful to have unit or system tests to show the reviewer how the code, the new feature that you might have introduced is used, because the unit test would have an example of arguments that you might use or inputs that you might use.
So some best practices for when you're reviewing for others is I mentioned this briefly before, but don't be afraid to use the reviews also just to ask questions. This might be around the context of of their changes, or if you're just, it's possible that something's fully correct, but you're just not familiar with a certain function they're using or something like that. So don't be afraid just to ask, even if you think it's fully correct, just because if they're using it, it's something that might come up for you later in the future as well. So it's helpful to know what it is if you're unsure. And this is a big one, is always to understand the big picture of the changes before diving into your actual review. So if you've worked on a software team before, you might know that most of the time a merge request is related to a ticket. That ticket will describe all of the changes that should be implemented. So a lot of the time I'll go check out that link ticket before diving into my review so that I have an idea of what's supposed to be accomplished with this. And having that bigger picture can really help you to think about some big picture things, like maybe there's a simpler solution altogether to the changes. You can think about how it might affect other teams, or if there's any security issues with this feature, that sort of thing. So if you are going to be raising an issue, make sure that you provide reasoning and suggestions, because, for example, if you think a function is named poorly, you wouldn't just want to comment, I think we should have a different name here. You would want to provide a bit of a reason as to why you think this name isn't appropriate. And then you can also provide a suggestion for that sort of thing of, I think this name would be better instead. And lastly, but most importantly, just be kind, because somebody has spent time working on this to submit for you, and you never know how much experience they might have with the code that they're working on. So yeah, never assume that they're experts or anything. And yeah, you just want to make sure that you're just being respectful of the time that they put into it. And you never want to be harsh with a suggestion, because you never know if they've already thought about what you're suggesting and maybe have a great counter argument that you're not going to see coming.
And so with that in mind, we wanted to cover a few common best practices and considerations when going to review code. It's a big topic, and it basically overlaps with what is good software. How do you write good code? And it's can be kind of daunting when you're first starting out. Like, you're going into your first full-time job, and your senior engineer gives you this code to look at. Like, how do you know where even to start? And so we hope to provide you with like a rubric to kind of start out with, some guidelines, which include having a good description, including test coverage, um, writing pure functions, which we'll talk about, to make sure it's readable, as succinct as possible, but also readable. Adheres to the style guide, some tips and tricks to finding bugs. And one side note that I'll add is that some of these things can be automated. And because code reviews are very manual work, it's uh, it's best practice for your team to try to automate as much as possible. Like, you can have plugins to automatically generate docstring stubs, for example, or automatically do linting, just to take the human work out of something tedious, like you use snake case instead of camel case. So the first bullet point I had there is the MR description, and I wanted to just include a screenshot of something that I posted last week to give you guys an example. So here I have a summary that kind of puts context around the problem. There's a page that was slow, and I'm updating the query to take advantage of database performance, just modifying the query itself a little bit to use a more efficient scan. And so that gives the reader some context. And then there's a change list with bullet points, because you might have like multiple file changes. You might have changed maybe 5 to 10 files, and the way to read it might not be in the order that GitLab or GitHub has for you. I often find that like having a change list is helpful, so I can go through the bullet list, and it's kind of the way the reviewer wants me to look at the code. So I'll look at the first bullet, find it in the changes, and then the second bullet point. So it's kind of like a guide for the reviewer for what order to look at things. And then I'll add some like sample usage and output, because these merge requests are on a branch and the reviewer has the ability to check it out and try it for themselves. So it's usually nice to provide a way to replicate or reproduce the change that you made through the MR description.
So the next thing we want to talk about was that you should make sure that your functions are kept pure and very short. So this is for when you're writing code yourself and something to keep an eye out for when you're reviewing. So for example, I have a function here that takes a list of a candy jar and then adds a candies and returns a new list that's combined this element and the original list. Or if checks if the list is already 10 items, and if so, throws an exception. So this function has a very clear purpose. It's named with this purpose as well. So even though this is obviously a really simple example, this sort of idea applies to more complex situations as well, because you want to have things broken up into areas that are this simple and this clear to readers. And this will help people understand during their reviews of your code as well. And notice that we're not modifying the original list here. So that means that there's no hidden side effects of this function. And then another great reason to keep your function short into one purpose is that this also makes it easier to write tests. So here it's very clear what two tests should be written. One to make sure that given an input, the output is correct. And then another one for that edge case of there being an exception, and to make sure that that exception has been raised. I know personally amongst my team, a lot of code review comments are often, I think you should add a test for this new functionality you've added. And this can be really important, because if somebody's taken the time to understand and write a bunch of code, and then you've taken time to review it, you don't want all this work to for no reason if people can just have a regression and somebody else who doesn't understand that area of the code just make a change next day. So tests prevent that, because they'll fail if somebody modifies the code to have a totally different purpose. Because that can also be important for if maybe you're not on the team to review changes in this area later in the future. You'd want to make sure there's no regressions to the code.
And now I'd like to talk about readability. So I have 3 examples on the left that basically do the same thing. If you don't know Python, that's okay. Basically, I want to show that these 3 do the same thing, but vary in length, basically. So you could write a piece of logic in a single line, or you could write it in 5 lines. And one thing that you'll find when you go into like a full stack role is that the one-liner isn't necessarily the best. It's cool to have, but it's not very readable and it's harder to maintain. This isn't a crazy example, but yeah, you can think of cases where it would get crazy and one line wouldn't be easy to understand for people. So you'll find that in the second example, it lengthens it a little bit and adds variable names that kind of describe what each step is doing. So in this input is a list of lists, basically. And the second example actually says that, we're first flattening the list for being two-dimensional to instead of being a list of lists, it's one single list. And then after that, we're going to filter the list to only be the even numbers. So you can kind of see the difference. The first one is like what is this? The second one, the variable names, can I tell you what's happening? And then the third one is kind of the longest. It's kind of a matter of preference, but some teams prefer for loops instead of, these list comprehensions in Python, just because they're kind of easier to read through. And then also another point is to make sure comments are clear and useful. There's definitely a possibility of over commenting, and I have an example at the bottom here, which is saying to append the number, which is what the code says. So it's not very useful comment. Comments are useful for explaining things that aren't like kind of pseudocode already. And so when you're thinking about readability, when you're doing a code review, a good get check to have is if it's taking you like 5 or 10 minutes to figure out what a piece of code does, then there's probably a way to make it more readable. And it's probably worth pointing out that, this is taking too long, and, there's going to be 20 to 50 eyes looking at this in the future. So maybe we want to invest in making it more readable. And then often engineering teams will have a style guide. And I have an example here from Google's Python style guide. And it's basically rules around certain things that might come up or stylistic choices that you might make in a particular language. So this one's specific to Python, but it's explaining kind of a choice around exceptions. And I like the way that Google has it because it tells you the pros and cons of a decision, and then the decision itself. So, in this particular case, like it's saying you should be specific with your exceptions. You should never use like catch-all exceptions, which is good advice. And in reality, like a lot of MR comments actually come from these style guides because they are kind of these like minute things that will help your code base be more consistent.
Another important thing to look out for when reviewing is repetition in code. So here's, again, a really simple example, but we could have two functions, one that given a player would walk west and another one to walk east. So if you were to see something like this during a review, you could suggest that a simpler solution would be to combine these into one function that accepts a direction and then moves that player in that direction. But this is just one example of when duplicated code can be avoided. So this can come in a lot of different forms. For example, you might want to be creating a function altogether if the same code is used in multiple places, as opposed to combining them like I did here. Or often this is seen as loops when code needs to be repeated multiple times. And sometimes it can be a bit tricky because repetition might not be obvious just in the merge request you're looking at. So a lot of the time, something might not be repeated within those changes that you're reviewing, but maybe logic is repeated somewhere else within the code base. So when I'm reviewing, if I see something that seems like it could be common functionality or that looks familiar to me, never be afraid to go search through the code base and leave the MR for a little bit to see if maybe this could be used somewhere else or if it's already being used somewhere else.
And then just some tips and tricks to finding bugs. This is, again, like a really complex idea, but just some guidelines to think about when you're first starting to do this. The first is to check the tests and make sure there aren't any edge cases that are handled. That's kind of the first place that I look and see like, oh, they're not handling negative numbers. What happens if this is null? And then I'll look at the test coverage. Sometimes your pipeline or the review technology that you're using will output like the test coverage, whether it's 80 to 90%, or, and then it'll highlight the lines of code that aren't covered. And I look at the lines that aren't covered and see if there's anything that's particularly complicated, like nested if statements or crazy nested for loops, things like that. And if they aren't tested, make sure they're a little bit more bulletproof than the simpler parts of the code. And then another easy way to find bugs is to try it out yourself. Because uh, it's especially hard to kind of imagine what the code does unless you try it. And this is especially helpful for front end changes where it's kind of hard to imagine HTML in your head. But once you load it up, you can see like, oh, this button is like floating out in space. And then finally, like another good tip to start out is like look for places where unexpected exceptions might be raised. So I have like two examples here on the left that are pretty common. This is a really simple example where you're trying to take an average of a list, but if the list is empty, then you'll get a divide by 0 because the count is 0. It won't look as simple as this, but you know, divide by zeros are more common than you might think. And then missing null checks are probably the most common. So you might like get an item from a map and the value is null, and then later on you try to use that value and you'll get some error saying the value is none. And then another common place is handling third-party errors. Let's say you're queuing something up or you're using a third-party API, like you're trying to tweet something. Those APIs aren't always reliable, and so you would want to have some like error handling to retry, do some sort of exponential backoff. And then when giving advice, once you find a bug, where I usually put the comment is the closest place there, because usually it's better to fail fast. And what I mean by that is you don't want to do a bunch of complicated logic only to find out that it failed. It's better to find out if it was going to fail before you do all that work.
Okay, so now is where we wanted to transition into doing a real life review with you guys. So we do have some code here in Python. We weren't sure how familiar everyone would be with Python, but the best thing about Python is that it's sort of like English. So we hope that this can be as readable as possible. But of course, if there's any groups that you're looking at this and you have absolutely no idea what it is, we're super happy to come join the room and provide some context. But basically, we have this function. You can see some sample inputs and outputs on the right here. So you would be giving this function a fruit basket, which would consist of, so in Python, this is called a dictionary. It's basically a key and a value. So the key here is apple and the value is 3. So this is basically supposed to mean that there would be 3 apples in this basket. And this basket would then be passed to this fruit picker function. So we have another link to a PowerPoint with this slide and all of those example slides of best practices we just went through to guide you. So then we hope that you're able to come up with some comments of areas where you think this function can be improved, and then that we can meet back up together in about, however, it's flexible to how much time you think you need, but 10 to 15 minutes. And then we can go over what could have been improved here, and then we'll show you a better solution at the end. So and also as a bit of an extra challenge, we left the function doc to do here so that you don't actually know what this is doing. So that's part of the challenge, is to figure out what's happening, because that happens a lot in real code reviews as well. For if it's not documented, you have to figure out what's going on. So we thought that would be fun. But again, if you have no idea, we're happy to help. So yeah, we can split into groups of about 5 now. I've actually never done this on Zoom before. So do we do that? Are we
It looks
now,
like
or?
Zoom is making it easy. Like I can make one that's 5 participants per room.
Oh, I think I've been able to set up the breakout room, so I can just let everyone go if that's
Okay.
what you guys
Okay.
want.
Okay,
Yeah, I
great.
think we're
And
ready.
I think since we're hosts, we're able to share a message with everybody, right?
Yes, but it might be good to just put it in the chat now. The chat will carry over to the breakout room.
Perfect. Okay, I'll share it now then. Okay, cool. So first, before we go over the solution, we just wanted to have somebody from each group just give a bit of an overview of what they found, and then we'll go over the real solution. But it's possible you guys came up with stuff that wasn't even part of the solution, but is even better. So it's very flexible. Are there any volunteers to go first? Okay, well, I'm going to tell my group then. So somebody from my room has to go.
I definitely, looking at it, found it was weird that there were two different variables that seemed like they do the same thing for size and then current sum. Both of them start at 0 and then you add based on how many fruits are in the basket. So it seems like that could be used both times instead of having to have two separate ones.
Yeah, I guess maybe easier than per group, just if anybody just wants to share comments that they personally came up with or that someone in your team said that was good.
One thing our team talked about also was how the variables k and v for key and value could have been renamed to something more helpful, like fruit name and fruit count or something like that. It would give a little bit more context.
Yeah, bad variable naming was one of the issues for sure.
Similar to what Rachel said, we were just talking about how like there was doubling of things. We thought that the for loops probably could have been condensed to one, like there was a different way to write the solution that wouldn't have needed to loop through the key value pairs twice.
Yeah, that was one of the comments that we intended for you guys to come up with as well. So great job. Was there anybody else that wants to share, or should we move ahead to present all of the issues that we would comment on if this was a real review?
I think one thing that our group talked about was the one comment in the function. First of all, it references this integer n, which doesn't correspond to the variable name of the randant. And also it's just like the only comment in the entire function. And it's like a little bit of a self-explanatory line, and that it's kind of clear that it's a random integer.
And to just add on to that, the double for loop definitely isn't necessary, and also isn't very intuitive. Like that part could have used a comment, if anywhere in the function. Yeah.
Okay, great. All awesome ideas, and most of them, yeah, those were the real issues with the code. So now we'll just go and share a couple more things, but you guys covered a lot of it, so great job.
Oh, I think you're muted.
Oh, I can go through these comments. So number one, this missing function doc would have helped us as a reviewer like figure out what this was trying to do in the first place. And then the second you might have noticed is there's some inconsistency with variable names. Like we have a mix of camel case and snake case. So for basket and like current sum. We have variable names that are meaningful. If you were to comment on this, then suggestions would be really helpful. And the first loop could be simplified. If you knew kind of Python, this would be more helpful, but you can basically use the sum function instead of writing your own for loop. More comments for sure would be helpful, especially in the latter half. Definitely took a couple more minutes than really was necessary. And then finally, if in this latter half, some of you already mentioned it, but you don't really need this second for loop to go through the range of current sum and current sum plus v. You could just replace that whole line with if current sum is less than random int. So that whole loop could be replaced with a less than check. And then if you looked really hard and maybe thought about the finding bugs slide, you might think of some edge cases. And one common one that I didn't mention is off by one errors. So there is a off by one error here. Actually, the comments does help to find it. So this says that we generate a number from 0 to 6. And because we want to return, like this function wants to return apple for 0, 1, 2, banana for 4, and orange for 4 and 5, 6 kind of breaks that. If you generate 6 as a random number, then you would get index out of range error.
Okay, I think I'm unmuted now. I got stuck muted by accident for a little bit there. Thanks, Mariel. And then here was our real better solution to this. So basically just changing everything we just mentioned, and we can, or I don't know if these slides have already been shared with you, but if not, we can share with them later so that if you want to go through this and take a look for yourself after, you totally can. So that was it for the code review demo. We hope you guys found that helpful, and we think it's a really important skill to go over because you don't necessarily learn very much about it in your courses, but then all of a sudden when you start at a software position, it's a huge part of your day and a part of your team altogether. So it's something that it's not necessarily thought of in school, but we want to share a bit of an intro on with you guys. So lastly, we just want to share a little bit about our company PathAI for whoever's interested. So essentially the name PathAI, the path part stands for pathology, AI for artificial intelligence. And we were founded in 2016 by our two wonderful co-founders, Andy and Aditya. And then in 2017, launched the PathAI platform. And then ever since then, we've been growing to develop a bunch of new products and growing a team, which is really unique and diverse because we have employees that are ranging from clinical pathologists and biomedical data scientists to machine learning engineers that don't really know anything about the pathology side necessarily. So it's a really interesting group of people. And our main mission is to improve patient outcomes with AI-powered pathology. So if I assume probably a lot of you are not familiar with pathology at all, but as a very, very brief overview, it's essentially a pathologist would look at a tissue sample through a microscope to diagnose disease such as cancer. So we would be accomplishing the same thing, but through algorithms, AI algorithms. And we do offer co-op positions. So we have people attend their co-op terms with us at PathAI and entry-level roles like myself. So we're happy to take questions or emails following this if you guys are interested in that. And Mariel can give a bit more of an overview about give some more details.
Yeah, just a couple more fun facts. We are a startup, so it's a small team of 150 people. I think we have maybe 40 or so engineers, software engineers, 30 or so machine learning scientists that are all pretty like top of their fields. And then the rest are people who have pretty strong backgrounds in biology and data science. And to develop our platform, we've partnered with 75% of the top 20 pharma companies to help them develop drugs and find patients that will respond to their drugs. So there's a bit of a personalized medicine aspect to it. We're close by in Fenway, like just our old office is on Brookline Avenue, just like a couple buildings down from Fenway. And then our new office is right behind that. So didn't move very far. But we also have some small offices in New York City and Austin.
Great. So that was all from us today, but we're happy to take any questions you guys have. This is just when we share this, there's some more resources if you're interested in reading up more about code reviews. But yeah, that's about all we had. We hope you guys enjoyed that and were able to learn a little bit about code reviews.
Thank you guys so much. We really love hearing from engineers who are out there doing the stuff we aspire to do. And that was a really clear and nicely presented presentation on code reviews. And I haven't really talked too much about code reviews or been to too many talks or info sessions about it before. So it's always nice to have someone break it down so that I don't have to just jump into the deep end. But yeah, thank you guys so much for coming. If you guys have any extra questions, you can always hang on to the call for a few more minutes. Other than that, you're free to go, and we'll obviously give you all the materials, resources, emails, information in the follow-up email tomorrow. Have a good one.